Hi, okay, no time to mess around on this one. My slides are retro-themed, black and white, not that I was lazy. Okay, so how many people here honestly understand when you click a link what you just asked a computer could do? About 20%, excellent, okay, this isn't a waste of time. Right, that's the goal of this. I want you to understand that about as much as you understand why someone goes, oh, it's a spark plug, you have a vague idea of what they're talking about. Okay, this is the biggest problem with understanding the internet and the web. If anyone's run into the TLA problem, or three-letter acronym, which starts with a lie, because it's an initialism, technically, because you can't say TLA. Right. So, I'm going to try and make this a bit easier. The first thing you need to understand is the difference between a language and a protocol. And almost every acronym on the internet that ends with P is a protocol, and almost every one that ends with an L is a language. A language, is something where you take an idea or a concept or a bunch of information that's in a complex structure and you turn it into a series of symbols, one after the other, like words or characters on a computer, to express it. In computer terms, it's usually in one file. In human terms, it's usually a linear, you are speaking a thing. The only one that you really care about is HTML, you might run, or hypertext markup language, you might have run into the extensible markup language. A protocol, on the other hand, is a way that two entities, in this case computers, talk to each other. The Internet Protocol, the Transmission Control Protocol, the Domain Name System, and the Hypertext Transfer Protocol, which some of these you'll have run into. These, to a first approximation, build on top of each other, but here's a good example of what a protocol looks like in your real life, and the distinction between this and a language. So a protocol is how one thing talks to another thing to achieve a task. There's usually exceptions where it can go wrong, like you don't have enough money, but this should seem like a reasonable protocol most of you should be familiar with. This is the same protocol using a different language. So this is still exactly the same protocol, and if it's wrong and anyone speaks French, I just use Google. I'm really sorry. Right. So IP is not intellectual property for today. It's the Internet Protocol. It was an idea which was a long time coming, but when the final case was knocked up by two blokes in a hotel in Silicon Valley, they locked themselves up in a hotel room and didn't come out until it was done. And the first version took about 2 days. And the idea of this, instead of connecting computers by, like having a switchboard where someone's putting one wire to another and the wire goes all the way from one computer to another computer, it works more like a post office, where the post office delivers to the next office, to the sorting office, to the sorting office, but in this case, the first sorting office is your Wi-Fi hub. Every computer on the internet has an IP address, or an Internet Protocol address. It's just a really big number from 0 to 4 billion and a bit. We write it like that just so that we don't mess it up so much, like credit cards have gaps in. You'll have seen these. They usually mean something's gone wrong in the comms department. You have to start worrying about this kind of thing. But 4 billion sounded like enough, but that's not even one address per person, and we've all got phones and laptops, so that's 2 each for a start. IP version 5, yeah, we don't talk about it. Internet Protocol version 6 uses, I can't remember how to pronounce that number, it's 4 times as many ones and zeros, and they usually look like this with a bunch of numbers but with colons between them. That's about all you need to know. It's like so many billion for every square metre of Earth. Now the way this works is you send a postcard to someone else on the internet through all these sorting offices. You write the address and you say where it's from and you send them a lovely message and it goes to each sorting office, the Wi-Fi hub, then the sorting thing for this university, Greenwich University, then the Janet hub, and so on until it gets to the computer at the other end. Or it gets lost, or there's a post strike. So this was I wrote Imperial, I was in a rush and I didn't do Greenwich. I got muddled. Sorry. I did these a couple of weeks ago and didn't check. I knew it was in London. Misspent youth typing mono-ac-uck for when I used to log into a certain mono.ic.ac.uk for an old bulletin board. So this is just an example, but they can go in loops, they can get lost. That's packet loss. You've heard of packet loss? That is literally your messages, your little postcards, what somewhere one of the sorting offices screwed up and it never made it to where it was going. The domain, right, that was it. That was the Internet Protocol. The domain name system. Right, this is because those numbers are hard to remember, so you give them meh.ac.arc as a more readable version. Yeah, it's not actually that much more readable, but it was for us nerds back in the 30 years ago, 40 years ago, whenever this was invented. And to use the domain name system, your computer already knows the Internet Protocol address of its DNS computer, and it sends it a postcard going, what's Microsoft.com, and it sends back a postcard going, oh, Microsoft.com is this address. And you go, thanks. We don't even say thanks, it's pretty rude. Right, that was it. That's how DNS works. There's a lot more to it, but you can read the Wikipedia page. Transmission Control Protocol over the Internet Protocol. Problem is, if you're trying to send a message, you can't send much in each packet. So if you're trying to send someone a long thing or trying to have a coherent conversation, they all arrive out, your postcards arrive out of order and things. So, right, so here's a cunning innovation. You write a number on each postcard. So when you send it to people, you put a number on each postcard so you can keep them in order. You also keep all the postcards in a little stack. That's called your TCP/IP stack. And all the postcards you've ever sent are stacked up until you get one back from them that says, last postcard I saw from you was postcard 24. So you go, oh, these can go then, you've had all the rest. But you only say that once you've seen all of the postcards up to then. And if you keep getting ones that say, last postcard I thought from you was 24, it's like, I've sent you loads. It's like, I'm sending them again. And you keep doing that until you give up and you time out the connection. Connection timed out. That's what it means. Right. Yeah. Universal Resource Locator. How am I doing for time, by the way? Okay. Right. This is, hopefully, everyone in here is not going to be scared of this. But ultimately, this was part of the innovation of the web was to describe everything on the web with a thing to locate it. And the first bit is generally how to ask for it, who to ask, and what to ask for. Yeah, there's a little bit after a hash at the end, which is where in the thing you care about, and you can put a question mark in and things, but roughly speaking, this is the important parts. And this is the protocol we all use every day without thinking about it. The hypertext transfer protocol. Hypertext just means text which links to other text in interesting ways. Oh, one of my best friends is a hypertext lecturer. I hope she doesn't see this. I'm sure there's a much better definition. Right, so I'm going to go through the entirety of what actually happens when you click on a link. We're clicking on meh.events.grad.html. So first of all, it's HTTP. If it was FTP or Mail2 or various other or Second Life, it would do something different. But for us, it's going to, first of all, your computer uses the domain name service, we've seen how, to go and say, oh, what's the real address of meh.ac.arc? And it says back, here's the address. It then writes some packets to say, hi, I would like to make a connection. It might say, oh, that's very nice, let's make a connection. And once you've got a connection go backwards and forwards, you can send a full, more proper conversation. And then you say, hi, could I have this page from this website? You have to say the website, because otherwise it wouldn't know which website you mean, because usually these days computers have 50 websites on, or 1,000 websites. It used to be we had one IP address per website, and that was silly. So now, cunning innovation, if you say which website, and it goes, 200 OK, oh, it's an HTML, by the way, here is what you asked for. 200 OK means everything works, you never ever see it. 404, 403, 500, 417, you've seen all of these. 200 is what happens when it works, so the computer never tells you. Okay. Hypertext markup language. This is a language for structuring information, and this is how we describe the things we're sending. PDF is another thing, describes a document, but so does HTML. It uses what we call elements, but everyone calls them tags really. They have a start and usually have an end, and the end is the same name with a slash at the beginning, and sometimes if they open and end with nothing in them, they just have a slash at the end of the beginning one. You can sometimes put extra values in them, like the term is a thing and term 2 is a stuff, which describes that. It looks like this, you've all seen this, but the important thing about this is it's really describing a structure. We're saying there's a paragraph, and in the paragraph is some text, and in that is an A, which is an anchor, which is a link, And that has some properties and some text in it. And so a web page is really a language to describe this tree of a document, a bit like a document outline going into layers. Right, everyone got it? Ready to answer a few questions? So one thing I got asked previously on this is security, how HTTPS works. And effectively, instead of setting up a normal connection, it sends some extra postcards to agree that it's going to talk in code using complicated maths, and ultimately that means the postcards are written in gibberish the postman won't understand. If you don't do that, the postman can read your information and find out your bank details as he delivers your postcards. Right, that's it.
Wowzers. We've got a bit more flipping over to do, so yes, has anyone got a question? Everyone's like that. Go on, ask Chris a question. Is there any on the internet? Whatever it's called these days. Go on, Brian. Lauren? Can you
give that talk, how's that going to happen? How's it gone down?
Actually, I last gave that talk at Ventnor Fringe Festival in a tent with a lot of hungover people and dogs. So, and they actually seemed to go down quite well. So yeah, I'm glad it's video.
Brilliant. Can we show our appreciation to Chris?